Hi all, I am Disha Shukla and welcome to the session. In this session we are going to discuss about the call routing. So human interface is analog, however the advancement in the digital technology makes it very convenient to handle the information in a digital way. So there are some basic functions that are performed whenever a call is routed. So what do you mean by call routing? So whenever a subscriber A calls to a subscriber B, it actually undergoes different processes, and moving on from one to another it uses different numbers. So what actually it is called the call routing. But before that, some of the functions that are done that. The first one is the digitizer and the source coding. So the user speech is digitized at 8 kHz sampling rate using the regular pulse excited linear productive coder, that is the RPE LPCE, with a long term predictor loop where the information from the previous sample is used to predict the current sample. Each sample is then represented in the signal in the signed 13-bit linear PCM value. The digitized data is passed to the coder with frames of 160 frames, where encoder compresses this 160 frames into 260 bits GSM frames, resulting in 1 second of speech compressed into the 1625 bytes and achieving a rate of 13 kilobits per second. The second process here is the channel coding. This introduces the redundancy into the data for error detection and possible error correction, where the gross bit rate after the channel coding is 22.8 kilobits. This 456 bits are divided into 8 57 bits block, and then the result is interleaved among the 8 successive time slot bursts for protection against the burst transmission error. The third process is interleaving. Now this step rearranges a group of bits into a particular way to improve the performance of the error correction mechanism. The interleaving decreases the possibility of losing a whole burst during the transmission by dispersing the errors. The next process is called the ciphering. So this encrypts the block of user data using a systematic or a symmetric key shared by the mobile station and the BTS. The next process is called the burst formatting. It adds some binary information to the ciphered block for use in the synchronization and equalizations of the received data. The next process is called the modulation. The modulation technique chosen for the GSM system is the Gaussian minimum shift keying, that is the GMSK, where the binary data is converted back into the analog signal to fit the frequency and time requirement for the multiple access rules. This signal is then radiated as the radio wave over the air. The next process is called the multipath and equalization. An equalizer is in charge of extracting the right signal from the received signal while estimating the channel impulse response of the GSM system, and then it constructs an inverse filter. The received signal is then passed through the inverse filter. Synchronization. For successful operation of a mobile radio system, time and frequency synchronization are needed. Frequency synchronization is necessary so that the transmitter and the receiver matches, while the time synchronization is necessary to identify the frame boundary and the bits within the frame. To avoid the collision of burst transmitted by the MS with the adjacent time slots, such collisions, the timing advanced techniques is used when the frame is advanced in time, so that this offsets the delay due to the greater distance. Using these techniques and the triangulation of the intersection cell sites, the location of a mobile stations can be determined from within the network. So when a number is dialed to reach a mobile subscriber, it is called the mobile subscribers ISDN, that is the MS-ISDN, which includes the country code and a national destination code that identifies the subscriber's operator. The first few lengths of the remaining subscriber number may identify the subscriber's HLR within the home PLMN. For example, the MS-ISDN number of a subscriber in Bangalore Airtel is 919845XYYYYY, which is a unique number. So the prefix, that is the internationalization dialing, then we have the country code, then we have the national destination code, that is 98, then there is 45, that is the network operators code, that is Airtel in our case, so that is 45. Then we have the level number managed by the operator, that is from 0 to 9, anything. And the last one is the subscribers code, the YYYYY, the 5 digits that we have. So this is how ISDN number is constructed. So actually what happens when you call is that, for example, the MSISDN number of a subscriber is, as I said, as we saw, that it's which is a unique number and understood from anywhere in the world. Here the plus means the prefix of the international dialing, 91 is the country code, 45 is the network operators code, and that is Airtel. So X is the level number managed by the network operator. So the call first goes to the local PSTN exchange, where the PSTN exchange looks at the routing table and determines that it is a call to a mobile network. So the PSTN then forwards the call to the gateway MSC. So the gateway MSC, that is the GMSC of the mobile network. MSC inquires the HLR to determine the status of the subscriber. It will decide whether the call is to be routed or not. If the MSC finds that the call can be processed, it will find out the address of the VLR where the mobile is expected to be present. If the VLR is that of a different PLMN, it will forward the call to the foreign PLMN through the gateway MSC. If the VLR is in the home network, it will determine the location area. Within the LA, it will page and locate the phone and connect the call. So this is how the whole process goes on. That is, if the mobile is not present in the HLR, it will further ask the VLR for the data, and from the VLR it will get the location of the mobile station that we want to call. So that will be acknowledged back to the HLR, and from the HLR we will get the MSRN, that is the roaming number, mobile station roaming number, and that using that mobile station roaming number, the call will be again connected to the subscriber that we want to call. And this is how the whole call routing takes place in GSM. Now if you have any questions in this, you can ask me. Until then, keep learning.